class, it's good to see you all again. I'm Natasha and welcome back. So today we're going to continue our fifth chapter. It's complex numbers and quadratic equations. So in the last video, in the previous video we discussed about the addition and subtraction of complex numbers. So what we did is all about, what we discussed was all about algebra of complex numbers. But algebra of complex numbers isn't complete yet. So today we're going to continue in algebra of complex numbers. So today we'll be discussing about the third operation. It's the multiplication of complex numbers. Okay? Yeah, so let's get started. So first of all, let me write the heading. What is it? Algebra of complex numbers. Algebra of complex numbers. Okay. So third operation, which is multiplication, related to multiplication. Okay. Yeah. Okay. So third is, I don't think there's any need to underline it. Yeah. So third is our multiplication. So multiplication is, in which we're given two complex numbers and we're just, multiplying them. And then seeing that what do we get, what do we get as the product, as the final answer, So, and yeah, in multiplication, we're going to discuss about some of its few properties too. So, but before that, let's just focus on its definition. So, what is multiplication of complex numbers all about? And what are we going to do in it? So, let's say we have Z1 and Z2 complex numbers. As usual, we as we used it in the last video too. So let's say Z1 and Z2. So I want to find. So I'm multiplying these two complex numbers, and let's see that what I'm going to get. Right? Yeah. So Z1 and Z2. What was the value of Z1 for kind information? Z1, let me write it here. So Z1 was A plus iota B. Z2 was C plus iota D. Right? Yeah. So the value of Z1 is A plus iota B, and Z2 is C plus iota D. So that for nothing between these two complex numbers, so this means that we're just simply multiplying it. Okay, and even if I'm going to put a dot between them, so, it will just, it's just merely saying it's multiplying it. So, finally what we're going to get, so as we're multiplying it, so one thing that we have to remember is we're going to actually, do it like this way. Okay. So A with C. So what are we going to get? We're going to get AC, right? A and C. With A and with ID, do you know what is it going to be? A with ID, and I is an iota actually. So what is going to be our answer? Can you guess it? Okay. So first, as okay, so so let me just calm down. Yeah, so AC. Okay, so A was with C and A with ID, iota D. Okay, so I'm actually going, by looking at this equation and at these two complex numbers, what are we getting? That will have iota common, right? No matter if it is addition, subtraction, or multiplication. Okay, so I will get I common somewhere. So I'm just gonna, I'm not gonna write this AD for now. Okay, I'm gonna write it later on. Okay, So as I can see that I will be a common. So AC, now B with C. Okay, it looks like this is with the same case too. So what's left? B with D. Oh yeah, it is. B with D. So can you like say that iota B and iota D, like what is it going to be? What relations are they going to have in multiplication? Okay, so we have our B and D, okay? And so what I can write is, I can write B and D right here, okay? And yeah, first thing that don't forget to put this plus sign, okay? Because it's necessary to use those plus signs, in between them. So what we're going to get is AC minus BD plus iota B. Okay, so A with D, as A with C is already here. So AD plus what's left? B and C. BC. Okay, let's have a look. Is it clear? So as I told you that this I is going to be common, so iota is going to be common in it. So what are we going to get? AD and BC. That's what we left. Because actually, when we were multiplying the two imaginary parts. Okay, so what do we do simply? Let's just understand it in a simple way. What do we do simply? What do we do is we make the relations of real parts. So what are the real parts we have is A and C. Okay, so what I did same right here. I want to tell you something really special right here is this Z1 and Z2 is equal to I plus iota B and C plus iota D. Okay, so they're going to make some different kind of relations. Like there will be real parts and imaginary parts, but instead of that, we're going to actually just have a look at the imaginary parts and real parts, not combined, but differently, like separately. So separately, so I'm saying that having a relation with with a real part. So having imaginary part having a relation with the real part. Okay, so imaginary part having a relation with real part. So A and ID. Can you say this? What type of relation will they make? Just simply what they're going to be. Okay, so they're actually gonna be the outers. Okay, so they're gonna be actually outers. I'm gonna just tell you outers. Okay, what will be the I, B, and C? There will be inners. Now what's the relation? A and so A with C, there will be first, and I, B, and ID, they will be last. So what is this all I wrote right here? They're actually, it's just showing that they're having a relation between, how do we have relations between a single imaginary part and a real part? So that's what it's all about. So what I can see is we have A and iota D, right? A and iota D as outers. Like what are these outers describing to us? Like what are these outers are trying to say to us? So they're just saying this that these outers are they're just telling us that they're out, which means how can I say, like outside and inside. So it's just the door, okay? And okay, let me make it like vertically or maybe horizontally. I'm not sure, but I'm gonna make it just like this way, okay? Okay, suppose we have a house here, okay? And so inside the house, in the house, I'll say this inside, and out the house, outside, right? So what is it saying? Outside means, it's just like out of it. Okay, not that out or over. Okay, it's just simply saying us. We can actually guess it, right? Of course, we can guess it. So these inners are those, who are inside, and these outers they're like outside. So they're known as outers. And I, B, and C known as inners, as they're inside, and these last. Okay. So in these A and C are first, which means that they're coming first in a relation with imaginary parts, and the last, which means that they're in last. They're making a relation in the last with the real parts. Okay, this is what it is. So there's nothing to be get confused. It was just a simple thing so that we can proceed here. Okay, so now I hope it is clear to you. So let's get back here, and so it's saying AC minus BD plus iota AD plus BC. Okay, that was a really easy relation I had right here. Okay, on multiplication of complex numbers. Okay, so A and C. So what I did first, I did the relation of inners. Okay. Oh, sorry. No need to get confused. First. So first I did the relation of first, which are A and C. Okay. Then I did the last, IB and ID. And then I thought that if they have I common, then why don't I only write B and D? Because they'll be like just obvious, like if we're writing IB and ID, so they'll have I common, and what's left? B and D, isn't it? Yeah. So what I did, I just directly write here. But yeah, I ignored it, and now I ignored the relation between A and ID and B and IB with C. It's because one of them were real parts and one of them was imaginary part. So so we can't just directly multiply them as their complex numbers. So they're like imaginary parts. So real parts are different from imaginary parts. So we can't just directly multiply them like this way, like we did in IB and ID. I was common, so that's why I wrote BD. And in here, a relation between an imaginary part and a real part. So that's why I had to write it like this way. Okay, and this minus here, it's just telling us that this is, just telling us that all this kind of relations are really easy. Okay, so there's nothing to get confused. Plus iota, as we were adding right here, so I just put it add iota A plus BC. Okay, yeah. So, what do we get? Finally, we get AC minus BD plus iota times AD plus BC. Okay? Yeah. So, let's move on. So, I hope it is clear to you. And now let's talk about its properties, okay? Now the properties comes. Oh, let me take the marker. Yeah, so first we're going to talk about the closure law. Closure law is like obvious in every operation, like in most of the operations like addition and subtraction do, and subtraction too. So multiplication also. Okay, yeah. So properties. Okay. Okay. So the first property is related to closure law, which is saying that this Z1 and Z2 belongs to C complex numbers. So this is closure law. And I think there's no need to, discuss about this first property as it's clear to us that if we're going to multiply two complex numbers, that the answers, answer is also going to be a complex number. It can be a real number or something else. Okay, it will obviously be a complex number. Okay, so second property is related to commutative property. Commutative property. Okay. Oh, it's actually not a property, it's a law. Yeah, it comes with the properties actually. So it's a law. So what does it say? So it says that Z1 into Z2 is equal to Z2 into Z1. So it doesn't matter to the order. It's just really simple. So if I'm going to use values, numbers at the place of these complex numbers, like 4 into 2 is equal to 8. If I'm going to change their order, like their places, 2 into 4, but still I'm going to get 8, right? So that doesn't matter, like changing the order. So in multiplication, if doesn't matter to the order, it's always going to be equal to each other, okay? So commutative law. Yeah. I hope this is clear too. And let's move on to a third property, and let me just clean this. Yeah. So third property is related to associative law. Associative law. Yeah. So in an associative law, what is it saying? So it's saying Z1, Z2, Z3. Okay, so we have one more complex number. This one's too, related to all about order, nothing else. Okay, yeah. So Z2, Z3. Okay, is it clear? Is it? Oh, I think I should put the dots in brackets, right? Yeah. Let me write it again. Okay, so Z1 dot Z2, Z3 is equal to Z1, Z2 dot Z3. Okay, so this one's also, all about the order. If we have more than two complex numbers, like if we have three complex numbers, doesn't matter to the order, still we're going to get the same answer. Let's take an example. But before that, let me write here associative law. Associative law. Okay? And yeah. So let's take an example. Let's take normal values, numbers. Okay? Numerical values, and let's say we have 2 point, it's actually dot, not point, yeah, 2.2. Let's put multiply sign, okay, into sign. 2 into 2, okay, and as I'm having 4, and then 2, and this 2 into 4, okay, simple. 2 to the 4. 4 into 4 will give us 16. 2 4s are 8. And 2 into 8 will give us 16. And 16 is equal to 16. Doesn't matter to the order, so that's what it's trying to say. So at the place of these values, if we have complex numbers, still it's gonna be equal to each other. Okay? That's it. Now let's move on to our fourth property, and it's related to multiplicative identity. Same we did in addition identity, additive identity and additive inverse. Yeah. Okay. So same with the multiplication too. So multiplicative identity. So I'm gonna write that in brackets. So first, let's see what's in this multiplicative identity. Okay. So it's just simply saying that what if we have to write 1 in the form of a complex number? So how are we going to write it? We're simply going to write 1 plus 0 iota. This is simple, really simple. If I'm going to add them, what I'm going to get? So what is it saying? That the imaginary part we have 0, but the real part we're having 1. So how can I write this real number into a complex number? Just like this way, okay? So what are we going to do if we don't have any value, another value? for, to put it with the iota. So we're just simply going to put 0 at the place of it. So 0 is the multiple of iota. So that's what I'm saying. So this is like multiplicative identity all related to this 0 thing, okay? So this is multiplicative identity. Sorry. Yeah, so multiplicative identity. And as we see that in the real numbers and the complex numbers, there's not too much difference between these properties. Like everything's the same. There's just a little difference that this complex numbers is a different thing and real numbers are a different thing. But the properties they're having, like the properties will always be same. Okay, it's same for the real number too and for the complex numbers too. Okay, so let's move on to our fifth property, and it's related to multiplicative inverse. Inverse in which we put the negative sign. If it's positive, then it's going to be negative, okay? Yeah, so let's see this multiplicative inverse. So in this multiplicative inverse, let me take something different, okay? Let me take something different. So I'm going to write this. We have z, okay, not z1. We have z. And z is equal to a plus iota b. Or I can also write a plus b iota, where a is not equal to 0 and b is not equal to 0, 2. Okay? This is clear? Right. Yeah, so let's move on. So it's saying that z is equal to a plus iota b, or I can also write a plus b iota, doesn't matter. Where one thing that is a is not equal to 0 and this b is not equal to 0. It comes actually in the real part, and if a real part is going to be 0, then I don't think there will be a meaningful complex number. So no, I'm not saying this that we can't have 0 as a real part. It can be possible, but that's not what we have to discuss. So let's just not discuss about it. So z is equal to a plus iota b, or a plus b iota, where a is not equal to 0. So it can be equal to a negative value or a positive value. Well, 0 is, neither positive nor negative. Okay, so it actually doesn't have any sign. Okay, so what I'll say, 0 doesn't come in negative and nor in positive, according to me. Yeah, so whatever it is, so let's just not discuss about it. We all know these small things, and we shouldn't be discussing about these small things too much, because there's too meaningless for us to know about them. Okay, yeah, so what is it saying? That the value of a will be maybe in the negative value or in the positive value, like 1, 2, 3, or maybe negative 1, minus 2, or minus 3. Okay, and so on. So what if I want to know that what is it going to be equal to? So it's really simple. It's definitely simple. Okay, so I'll be just writing it here. So it is going to be equal to let me write it again. Yeah. So it's going to be equal to a upon a square plus b square plus iota negative b plus, what is it going to be? Let's say b square plus a square. Is it right? Wait, just have a look. Is it right? Well, of course it is right. Of course it is right. So, what am I trying to say? If I've really changed their order, it doesn't matter at all. But still, I'm going to write this in an order. So it's going to be a square plus b square. Okay? Yeah. So we have a upon a square plus b square plus iota minus iota is 2. So I is 2 is just like what we're saying. So for now. So I is 2 negative b upon a square plus b square. Okay. So what is this a squared and b squared? So what it's actually saying this, that it's denoted in the multiplicative inverse, especially related to the case of multiplicative inverse. It's denoted by 1 upon z, or z to the power -1. Okay, we can write it this way. And how about writing it in another? Okay, let's say it's square bracket. Yeah, so it's multiplicative inverse, right? Yeah. Okay, so it's multiplicative inverse. So what is it saying is that if this b, we always change the value of the imaginary part. Like it's like as we can see that it's positive. So I just wrote it here negative, and I got common. So and in the denominator, like denominator can be equal to 0. So what I wrote that this, and yeah, one thing we also knew that a is not equal to 0 and b is not equal to 0. So what does this mean? I put in the in the denominator as a squared plus b squared, and same here. Okay, and the value of b was to be negative. Okay, and it was the part of imaginary part. Okay, yeah. So in the simple and multiplicative inverse, what do we do? Simply, okay, simply, what do we do if I have 3 plus, let's say 4. So what is it going to be? -3 minus 4, right? Like we have just changed its sign to negative. It was here also positive, so negative, and that's what I got, right? Yeah. So this is all multiplicative inverse is about. So how about take an example? Okay, so let's take an example. So we have to find the z1 and z2. So our z1 is let's say our z1 is 5 minus iota, and z2 is 20 plus 4 iota. Okay, just have a look. This is like a small question to us, so we have to find we have to find the product. So we have to find z1 and z2. Okay, so this is z1 and this is z2, right? So first, 5 with 20, what is it going to be? 100. Century. Yeah, 100 is a century, right? Okay, so 5 with 20, now 5 with 4i. Same, remember this case, so I'm not going to write it for now, so let me just, put it right there. So, sorry. Yeah, so now I have this I with 20. Not again. I with 4i. What is it going to be? Okay, so let's just put this positive. So positive, it's going to be a positive value. So what is it going to be? It's going to be 4, right? Yeah, it's going to be 4, isn't it? Like, is this really meaningless or what? Okay. So let me just tell you in a real simple way. So what we got here was 5 for the 20, right? So I got 20 plus 20 iota. Okay, so I'm writing it just right here. So, and then what I got with I with 20 was a negative 20 I. Okay, and with the I with 4, what did I got? Plus 4 iota, right? Isn't it? Like, even if you're a little confused about this negative value, like if it's gonna be negative or positive, let's just let's just not get confused. Like maybe I can get confused too. So let's just cause it together, and if I'm gonna make a mistake, I'm gonna just take it out. Yeah. So what I'm saying is this 100 plus 20 iota we got. So 5 with 20 I got 100. 5 with 4 I got 20 iota. iota, negative iota with 20, I got negative 20 iota. I with 4, I got, oh, okay. Now I got it. So it's going to be negative, okay? So I with 4, so as it's y, 1 here and 4, so 1 into 4 will be 4, and iota was here, so I was common, so iota, I just put it. So, finally I got 104, oh, okay. So, I'm going to just write it again because I have to make a little more space here. So, what I got, 104 plus 0 iota. This is interesting, 0 iota. How? So, I have this, and this. So, what I got, 4 and 100. So, through this, I got 104 positive. And so, what's left in iota? Sorry, I'm really sorry. Yeah, so what I got here is there's nothing left, so there's 0. So I just simply wrote it, 0 iota. So what I got, so like, can we just have a look? Well, what property, like what law is it following? It's following the first law too. And so, of course, it will follow the first law, as first law is just really fixed. You know, it's just at a fixed thing. So, 104 plus 0 iota. And if I'm going to talk about its real part and imaginary part, then what is it going to be? Real part, of course, I can see 104. And imaginary part will be 0. Not I, because I is just a symbol. Yeah. So, I just a symbol. Okay, I'm going to write it. I better write it, okay? So, yeah, it's 0 iota, so we're I. Okay, let me just quickly write out that I is just a symbol, okay? I really can't say it right now. Yeah, so I is just a symbol, okay? Yeah, so iota is nothing, is not related to the imaginary part, so which imaginary part is just a 0, okay? Yeah, so I hope this example is clear to you. So let's move on to our 6th and last property. So it's, wait, is there a 6th property too? Yeah, of course there is. In multiplication, in multiplication we'll have one more property. Did you forget about the distributive law? Oh, come on. No way. So distributive law will always come in multiplication. So there's no way to forget it. There's no way. So about the distributive law, as we know, in which we have the addition to and the multiplication, of course. So let's say this. What should I say? Okay, let's take Z1, Z2, and Z3. Okay. So Z1 plus Z2 in the Z3 is in your multiplying, is equal to Z1 into Z2 plus Z3. Can you just have a look at this one? Okay, so what is it like? What is it? Oh my gosh. Oh, actually I had to write it here, but I wrote it here, so it will come in the next part because it's actually not going to be equal to this thing, okay? It's not going to be. So what do we have? Z1 and then the Z2 plus Z3, right? Yeah. Okay. And this is the B part. Okay, Z1 and Z2. So what I'm going to get, Z1 with Z3, Z1, Z3 plus Z2 and Z3. Okay, and Z1 with Z2 plus Z1 with Z3. Just have a look. Is it right? Z1 with Z2 and Z1 with Z3. Z1 with Z2 and Z1 with Z3. Okay? Yeah. So, I hope these two things are clear to you, and this, both these things are, is a mainly distributive law. Common distributive law. Oh, okay, so what was in this thing? It was, really easy. So, as we all know about distributive law already, so in which we have addition to and multiplication, of course. So, what was there? So, I was just combining like the way I do. Not only me, like all of us. So, combining like this Z1 with Z3 and then Z2 with Z3. And Z1 with Z2 and Z1 with Z3. And putting the add sign here. What if there would have been the negative sign here? So, I'm just simply going to put negative sign here, minus sign. That's it. So, I hope all these 6 properties are clear to you. And this main topic, multiplication, this main operation, multiplication of complex numbers clear to you. So, that's all for today. And in the next video, we'll be discussing about the division of complex numbers. So, or maybe something else, but I don't know for now. So, let's expect something cool in another video too. So, thanks for watching and have a great day.